Hi everyone. Today we'll be taking a look at question 111 on LeetCode called minimum depth of binary tree. So this is the opposite of the other question, maximum depth of binary tree, where this time we just want to find the minimum. So in this case, given this example 3, 9, 20, 15, 7, the minimum depth is 2 because 9 has no children. So how do we do this? Well, it doesn't make sense to do DFS in this question because there's no reason to go all the way down to the tree to always find the minimum depth. Instead, we can just go level by level to find where the first no children are. And once we find that, we know that's the minimum depth. So that implies BFS. Let's talk about base case first. If there is no tree, just return 0 because there is no depth. Then since we're doing BFS, let's use a queue, starting with the root. And let's keep track of the level that we're at, or depth. Actually, let's call it depth. Starting at depth 1. Then we can BFS, so while 0. We do need a way to empty the queue every single time we go to a new level. So the way we're going to do that is we're going to push in something called stop. And once my queue hits stop, we'll empty it, and then we'll move to the next level. So we can say while queue 0 is not equal to stop. We can shift the first node up, see if it has no children, so we return that level. Otherwise, we just push the children in. So let's know that left. Push and if right, q.push node.right. Finally, once we're done visiting the children, we can shift out that stop that we had before. So now we're on the next level. And finally, just do level plus plus because now we know we're at the next level. So let's use paint to see what's going on. So first, my queue is going to start with the node 3. And then in the first iteration, we're going to push in a stop. So this becomes 3 stop. And now we do the iteration. So we shift the 3 out. We know that 3 has children, so we don't use this statement from 27 to 29. Instead, we push in its 2 children, node left and right. So now become stop, left, right. Since the first child is now stop, we stop this loop, shift out the stop, and increase the level. So actually, let's write the level down here too. So in this case, the level was still 1, but once we shift out the stop with the left and right, which are 9 and 20, this will look like 9, 20, and level equals 2. Sorry, I just realized I wrote left and right, not the actual node value. So now we did 9 and 20. So the first thing we'll do is shift and stop, sorry, push and stop. So now look like 9, 20, stop. And now we do the same exact thing. We'll push in all of 9's children and all of 20's children. But since 9 has no children, we'll stop there. And we'll return 2 because 9 has no children. So let's just say if 9 did have children, then we would keep going. We would push in 20's children as well, so there'd be 4 nodes, and then we stop, and same thing over again. So once again, the idea behind this stop button It's just to make sure that we go level by level in our BFS. So let's see if this works first. Oh, I'm stupid. I call it def. And works just fine, and works just fine. Cool. What is the runtime of BFS? It's still going to be O of n. Since worst case, our minimum depth is all the way at the end. So this is O of n, and it's the number of nodes in our binary tree. Cool. So with that, I'll put a link to the question as well as my GitHub down below, and I'll see you guys next time.